In this video, we are going to work on homework day 26. It says use the graph of each of x pictured to the right to complete exercise 1 through 4. The graph of each x is continuous. You can tell it's continuous, no breaks, no holes, no jumps on its domain, like on x-axis, but not differentiable at all values on its domain. So domain means x values. When I get to the point, and you guys remember, the function is not differentiable if it's undefined or if it has a cusp, like a really sharp turn like this. So you have a sharp turn right here. So at x equal 2, it's not differentiable. I can tell easily looking at the graph. Not differentiable. Give a graphical reason for your answer. So I can say x equal to, I don't have to show algebraically anything. They said graphical reason. So I have to show them like this. Like you can do limit, I showed you guys limit x approaches to from left and right of f prime x and stuff like that. But it's just a graph. It's not a function. So that's easier to just figure it out. That's a cusp. And they are also asking graphical reasons. So x equal to is a value at which h of x is continuous. You can tell it's continuous because there are no holes. Continuous, but not differentiable. Because the graph has a cusp. Because the graph has a cusp. And done. You don't have to do anything else. Graphical reason, that's what the graphical reason is. Now, they said write an equation of each x and show analytically. Analytically, which means you algebraically show them steps. Is in fact continuous at the x values, and you identified in exercise 1, show and explain your work. So continuity means I should have 3 conditions. That's what it means, 3 conditions. And also analytically, algebraically, I have to show them. And they said write the equation. Like they're not giving me equation. They want me to make it up. So this portion is a piecewise function. Like, do you see that? That's a parabola and that's a linear function. In the linear functions, you should have a y equal mx plus b. That's what the linear function goes. So I'm going to make that equation h of x equal, and it's a piecewise function, like different pieces. This is a negative slope, so I'm get 2 points, fall and run. So it's negative half is my slope, and negative half x plus what is my y-intercept? It's right there, it's a 2. So, and it's between, the restrictions are from negative 6 to 2. Do you see that? So the restrictions are negative 6 to 2. So it's less, greater or equal negative 6, and this is less or equal to. You can tell it's less than 2 and greater than negative 6. That's between these x restrictions. What is the function for this? What is this called? Parabola. What does that mean? It's going to give me, and since they don't ask you these questions, so I'm just going to directly give you the formula for that. So it's going to give me negative x squared, because it's upside down, plus 8x minus 11, and the restrictions are 2 less equal x and x less equal 6. So that's my equation. Now they said figure it out. It is continuous. In fact, continuous at the x values. And also I have to show them the work analytically. So the continuity means 3 conditions. The first condition, and they are talking about at x equal 2. So I only have to give them this portion and this portion. So equal to means h2 is defined, and the value is x equal 1. And you can tell it's defined because that's not it's a sharp turn, but it doesn't mean it's not defined. You have a 2 and the y value is 1. So I'm going to go h of 2 is going to give me 1, point is defined, because they said explain it. So I'm explaining it one by one. That's 1. Number 2 steps, limit x approaches to from left and right. So limit x approaches 2 from the left. This is the left, actually. X less than 2 is left. So I'm going to go h of x equal negative half x plus 2. And when I plug in values of 2, so negative half 2 plus 2, they cancel out. And I'm left with 1. That's my left. Then I'm going to go for another one. Limit x approaches 2. Sorry, that was left. I didn't write the negative. X approaches 2 from the right of h of x. For the right, I'm using this function because x greater than 2. So I got negative x squared plus 8x plus 11. When I plug in negative 2 squared plus 8 times 2 plus 11. And this one is also gonna give me 1 when I solve it. So it means the limit exists. Okay, so when the limit exists, then what is that? It means limit x approaches to h of x exist. Third condition was, is the limit and the defined point are the same? Yes, they are. Like I can say h2 is equal limit x approaches to h of x, and both of them are equal 1. So yes, the function is continuous. I'm going to say therefore h of x is continuous at x equal 2, and done. Okay, in this one, question number 3, since we already know in question number 1, there was cusp in the graph, so it was not differentiable. Cusp is not differentiable. And this one, we showed them that it is continuous. But in question number 3, they're asking, show analytically that HSX is in fact not differentiable. And we know there was cusp there, so that's why it was not differentiable. But how do we show them, like analytically, like algebraically, you show them? So what we're going to do, this is HX, and HX, the function that I had, which is right here. And I'm going to take a derivative of this, h prime x, because that's how we figure it out about the differentiability thing. So this is h prime, and I'm going to take a derivative of that. I'm taking a derivative of this piecewise function, and I'm looking for differentiability. So I have to show them limit x approaches 2 from the left of h prime x is supposed to be equal limit x approaches 2 from the right of h prime x. That's how we find differentiability. So I'm going to do that. First, I have to take a derivative for the limit x approaches 2 from the left. So let me clear. Here we go. Now we have limit x approaches 2 from the left. X approaches 2 from the left of h prime x is equal limit x approaches 2 from the right of h prime x. So from the left, we use this one from the left, the negative half x plus 2. So what is the derivative of that? It's just only going to be negative half. Then I'm taking a derivative of this one, 2 from the right, which is that x greater than 2. So the derivative of this is negative 2x plus 8. So now I have to plug in the 2 here. So I got negative 2 times 2 plus 8. Negative 4 plus 8 is going to give me negative half equal positive 8 minus 4 is going to give me just a 4. And they are not equal each other. When they are not equal each other, then it means it's not differentiable. So that I'm going to say, since they said explain, since limit x approaches 2 from the left of h prime x is not equal limit x approaches 2 from the right of h prime x. Therefore, hx is not differentiable at x equal 2. Because at x equal 2, we already knew there was a cusp. And the question is asking x value that you identified in exercise 1. So we identified 2 in the exercise 1. That's why I did left 2 and right 2. So this is how you do question number 3. Let's go for question number 4. Given that each x is pictured above, find the equation. We already know equation means this. Tangent means derivative. Line of the graph to the graph of p of x is this when x is equal 3. So they are asking for the equation of the tangent line to the graph of p of x. Then I have to take a derivative. If we know for the equation, I'm going to write the equation up here. And we need y1 m and I need x1. x1 is given, actually it's 3, but I need to find y1 and m. So let's take, for the m, let's take a derivative of that. M means slope, slope means tangent, derivative. So I'm going to do that. So I'm going to rewrite it because of the square root like this. Take a derivative of this. Half jump to the front to keep inside as it is. And half subtract 1 is negative half times the derivative of h prime x. Now I'm going to fix this because of the negative exponent. 1 stays on the top, 2 in the bottom. This one goes also in the bottom because of the negative exponent, and I'll make it as a square root. H prime x goes on the top right there. So that's my derivative. And since they're asking at x equal 3, so I have to plug in that 3. Draw a line, p prime 3. It's going to give me h prime 3 over 2. And what is hx function, which means h3 I have to plug in. Okay, what is h prime 3? We already know the h prime. Since we already know the h prime is this from the left and right for the 2. So since they said at x equal 3, so which one I'm supposed to use for x equal 3? I can't use this for x equal 3 because this one says x less equal 2. That one is x greater equal 2. So this function is we're gonna be using for x equal 3 because you know the restriction says that x is equal 3, so 3 comes up here. This one is less than 6 and greater than 2. So 3 is between 2 and 6. 3 is not between negative 6 and 2. So I'm going to pick this equation for the h prime x. And we already have a derivative of this h negative x squared plus 8x minus 11. It was somewhere over here, which I picked the derivative of this. And I can do the derivative again. It's not big deal. It was the derivative of h prime x for the 2. It was negative 2 times 3 plus 8. I plugged in the 3 here, p prime 3. Over 2. What is h3? So you're going to plug in 3 in the h function, the original. And I know for the original, this is my original function. Should I use this piece for h3 or this function piece? So I'm using that one because, you know, x greater or like 3 is between 2 and 6. So I'm going to still use that one. When I plug in that, it gave me square root 4. When I plugged in negative, I plugged in 3 in this equation, which was negative 9 and plus 24, negative 11, and it gave me 4 square root. So I got that. Now I have negative 6 plus 8 over 4, because 4 is a perfect square. 2 times 2 is 4. So the answer is 4 over 4. 8 subtract 2 over 4, which is going to give me half. So my slope is half. Now, how do I get the y value for it? So I'm going to plug in p3 in the p function. It's going to give me square root h3. We already know h3 is square root 4. So you can do square root 4, which is going to give me 2. So that's my y value. So now my equation is ready. I have y minus 2 equal half x minus 3, and I'm done. I'm going to repeat this one more time. Since we needed a slope, so I took a derivative of p and I got this derivative. Now what is h prime 3? I plugged in 3. H prime 3, we're going to use this piece of information for h prime 3 because see 3 is between 6 and 2. It's not between 2 and negative 6. So I'm using this equation to take a derivative of it and plug in 3, which we already did, and it gave me -2, 3 plus 8. Like if I take a derivative of that, this is going to give me -2x plus 8. So that's why I plugged in 3 here, and in the bottom, each 3 means I have to plug in the original to get that y value, and I plugged in that 3 in here, and I got square root 4. Like I plugged in everything, like 3 square, 8 times 3, and then minus 11, it gave me 4. And this is how we got question number 4. If you guys have any questions, make sure that you comment below for each one of them. In this question number 5, they are giving me a continuous function on the interval -4 and 5 is described in the table. H of x is described in the table below. Use the information to complete exercise 5 through 8. These are all my x values. This is my hx. And the question is asking sketch the graph of h of x. So all I have to do is plot these points. So -4 and -5. This is -4. That's -5. Then I got -2 and -4, -2 and -4, -1 and -2, 0 and 1. So I'm connecting the dots. Okay, it's supposed to, let me see. If I start here, it's gonna go like that. There. Then I have, because -4 to 0, I'm increasing and concave up. So it is concave up, like concave up means like that. So it is going like this, and it is increasing, like if I draw a tangent line, it's all positive. Okay, so that's good, -4 to 0. Then 1 and -1, 1, -1, 3 and -2. Connect the dots. Then I have 5 and 0. 5 and 0, which goes like that. Okay, so and they said 0 to 3, that's 0 and 3. I'm decreasing. I have all negative slopes, and it's concave up again. 3 to 5, it's concave up, and it's also increasing when I draw a tangent line. So that's what it means. So I'm going to draw these -4 to 0. -4 to 0, I'm increasing. So all the tangent lines when I draw, they are all positive tangent lines. When I draw positive, these are all positive tangent lines. Then it says it's concave up, it is concave up. Then decreasing up here, when I draw tangent lines, like right here, it's all negative slopes, all negative slopes. So they're all negative slopes, and it is also concave up. This portion is also concave up, but the tangent lines are positive, which means they are increasing. So this is how it goes. I sketch the graph, and that's done. Question number 6 is talking about estimate. When they talk about estimate the value of h prime, estimate is always a secant slope. From the table, I don't have a hx function that I can take a derivative of it and plug in -2. So what does this mean? This means it's a derivative. I estimate secant slope. So from the table, always you pick arbitrarily close. So -2 is the x value. So which one is arbitrarily close to this? It's going to be -4, -5, and -1, -2. So these are my arbitrarily close. I can pick those. Or you can also pick -2 and -4, but I'm picking these two order pairs, these ones. So I'm going to go h prime -2 approximately. This is my A, that's B, that's f of A, and this is f of B. So I got f of B, -2 minus f of A is -5. B minus A, -1, subtract -4. So this is going to give me -2 plus 5, -1 plus 4, which is 3 over 3. and approximately my answer is 1. So what is my approximation or estimation at h prime negative 2? It's 1. Then they said, does this value support the claim that hx is increasing on the interval negative 4 and 0? Since this is positive slope at negative 2, then yes, it is supporting the idea that at negative 2, since I'm drawing a tangent positive, then it's supposed to be positive. So yes, that's true. So since I'm going to explain my reasoning, h prime 2 negative 2 is greater than 0, then yes, the claim that hx is increasing on negative 4 and 0 is supported. Done. Now, question number 7 is differentiate. There are these are the x values in the domain of h at which hx is not differentiable. What are these three values, and give a reason for why hx is not differentiable at these values. There are three x values that we can say it's not differentiable. So we know differentiability is when it's a cusp, or when it's a cusp, and when it is not continuous, or we making more than one tangent lines on that point. So I'm gonna say one has a cusp, like x equals 0 has a cusp. So I know it's not differentiable. Negative 4 is not differentiable because I can draw, you can tell this is negative 4, and I can draw like a lot of tangent lines up here. Like I can make a undefined too. So this is negative 4. So I'm gonna say hx is not differentiable. hx is not differentiable at x equals 0 because that was cusp, and also x equal negative 4. And what about 5? 5 is also, because I'm making undefined, I can make negative, I can make positive. So I can make several tangent lines over 5. So how do we give them the reason? hx is not continuous at x equal negative 4 and x equal 5, and at x equals 0 hx has a cusp. So this is not continuous, because continuous means it's supposed to go in this direction too. This is not continuous either. Or you can also add, instead of continuous, you can say at x equal negative 4 and 5 there are several tangent lines, or tangent I can draw, or we can draw tangent lines, several of them at 5 and negative 4. So you just make it up something. On what interval, question number 8, on what interval of ax is h prime greater than 0? Give a reason for your answer. Where h prime is greater than 0? H prime greater than 0 is, which means the slope is positive. So the slopes are positive from negative 4 to 0 and 3 to 5. So I'm going to say hx is increasing on the interval negative 4, 0 and 3 to 5. Then h prime x is greater than 0. Question number 9. At what values of x will the graph of f of x equal 2e to the power 2x minus 3x have a tangent line whose slope is, tangent means derivative, slope is 1, which means that's also derivative equal 1. So at what values of x? So x I'm looking for. And since this is a tangent, so I have to take a derivative of this and make it equal 1. So take a derivative of that, f prime x. 2 is a coefficient, it stays e2, x derivative is e2x times the derivative of the top, which is 2. Derivative of 3x is 3. So I'm going to fix it. 2 times 2 is 4, e to the power 2x minus 3, and then make this equal 1. So add 3 both sides, and I got 4 e to the power 2x equal 4. Divide by 4 both sides, and I got e to the power 2x equal 1. How do I get rid of this e so I can get my x values? ln. Okay, do ln both sides. They cancel out each other. I'm left with 2x and ln 1. Now ln 1 is 0. We know that. You divide 2 both sides and it's going to give me x equal 0. So my answer is for that one, the x value or values, I just have 1 and it's 0. Question number 10. The graph of x minus 2 equal 9 is parallel. Parallel means when the slopes are exactly the same to the normal line, to the graph of f of x when x is equal 5. What is the value of f prime 5? Justify your answer. So the first thing first, the question is talking about the graph of this is parallel to the normal line to the graph of f of x when x is equal 5. So since this is the equation that I can change that to, as a normal line, can change this to y equal mx plus b, then I can do that. If I couldn't change this into y equal mx, then I have to take a derivative and get the tangent slope and do the reciprocal of that. Since they're asking f prime and normal line is given, like they're asking for a tangent slope. So it means I have to get the normal line, and the normal line I can easily change it into a y equal mx plus b. If I can easily change a normal line into y equal mx plus b, then that's a good one because it's going to give me a slope, and I got minus 9 over 2. Negative turn positive. So my slope is half x. Since they said the lines, that this line and the tangent lines are parallel to each other, then it means the slopes are exactly supposed to be the same at x equal 5. So I'm going to say that, and since x minus 2y equal 9 is parallel to the normal line, at x equal 5, then it is perpendicular, perpendicular to the tangent line. At x equal 5. Since the slope is half, then the slope of tangent line, because since we are asking for the tangent slope, so since the slope is half for the normal line, the tangent slope is then tangent slope is reciprocal in opposite sign, so it's going to be -2. So it means f prime 5 is equal -2. That's what they were asking me. If the normal line was not something that we can change it into y equal mx plus b and can't get that as slope as an m, then I have to take a derivative, get the tangent, and do the reciprocal and all that stuff. Question. Let f be defined by the function f of x 3 minus x, x less than 1, ax squared plus bx, x greater or equal 1. If the function is continuous, which means I have to give them 3 conditions. What is the relationship between a and b? Explain your reasoning using limits. So if I do that, I'm going to go limit x approaches 1 from the left of f of x. Left is this one. So I'm going to use 3 minus 1 equal 2. And then I'm going to go limit x approaches 1 from the right of f of x. It's going to give me a 1 square plus b and 1. So I'm going to get here a plus b. When we make them equal each other, so a plus b is equal 2. That's the relationship between a and b. When you add a and b, you will get 2. That's what it I mean, we can tell it's the continuity. The function is continuous. So I have to give them using limits, left and right. Now, B part, find the unique values of A and B. Every time when there is missing variables, you have to make them equal each other and plug in the one values. But they said that will make F both continuous and differentiable. At x equal 1, show your analysis using limits. So again, I'm going to use the limits for differentiability. For differentiability, I'm using limits for the F prime. For continuity, I mean, we can just make, we already did the continuity on the top, so I'm just going to use that one. First, let's do the differentiability. If they have, if something is there in one of the part of the question, then you don't have to redo it or do it again for the second part. You just leave it alone because we did the continuity in this part A, so I don't have to do that. My answer was this one. For the differentiability, I have to get the derivative. So limit x approaches 1 from the left of f prime x. So if I take a derivative of the left, which is this, and I take a derivative of that, it's going to give me -1. Then I'm going to go limit x approaches 1 from the right of f prime x. What is f prime x? This one, the limit from the right. So I would take a derivative of this, which is 2a, and x is going to go as a 1, plus b, x derivative is just a b. Then I'm going to make these two equal each other, 2a plus b equal -1. So that's my differentiability part here, and that's my continuity, and I'm going to make it as a system of equation. So I got a plus b equal 2, and I got 2a plus b equal -1. If I multiply everything by -1, for the top portion, then I can cancel out the b's. So I multiply everything with -1. So I got -a right here minus b equal -2. They cancel out. I'm left with a equal -3. So once I get one of the variable, I just have to plug it in any one of those and I will get my b. So I'm going to plug it in a. A is -3 plus b equal 2. I'm plugging in that one, like on the top one, this equation. So it's going to give me add 3 both sides, and it's going to give me b equal 5. So I got a and b. So every time, if they don't mention differentiability and continuity in this case, and they just tell me, oh, find the unique values of a and b, then I'll just make those two equations equal each other, and I will plug in 1 for the x's, and I will deal with the system of equation. But if since they are asking for differentiability, so I have to give them using limits for the differentiability and that continuity limits. If you guys have any questions, please comment below and I will answer.